Good afternoon. Welcome to Improving's Virtual Lunch and Learn. Before we start, please make note of the question mark icon at the upper right corner of the presentation screen. Clicking that icon will open the question and answer feature, which allows you to send questions to me, our moderator. Your questions will be delivered to Tim at an appropriate time. We are excited to present Tim Rayburn, Vice President of Consulting at Improving, who will be sharing a C#9 skills update. Take it away, Tim.
Thank you very much, Will, and I appreciate you moderating today. Welcome, everyone. Today is going to be a very code-centric presentation as we jump straight in to really understanding some of the new features that have been released as part of C#9. If you're a developer in the .NET space and working with the C# language, staying current on what's going on with the language is very important. Microsoft is more and more putting out updates that really can affect even the designs you're capable of producing easily with these new features. And so I'm going to transition over to Visual Studio here, and I'm going to start with a very simple hello world here. And I just want to give you an idea of what our agenda is going to be today. And so here's the agenda that we'll be working through. The first thing we're going to talk about is top level statements, and then we'll flow through the rest of these features. There are a bunch down here that are marked bonus. I'll get to them or I won't. We'll see, but depending on how things are flowing through. But I wanted to make sure that I have enough stuff to fill the time, and so if we have time, I would love to share some of those features. Those are actually C#8 features, all of those. So if you're looking at those and going, I haven't even heard of a null coalescing assignment, well then that's a C#8 feature, not a C#9 feature. I'd encourage you to go check it out. But everything that I'm sure we're going to hit, those are the major C#9 features that we want to make sure that we talk to you about today. All right, so step one, we're going to talk about a concept called top level statements. Now, I will be completely frank with you. If you're a professional software developer and you are not training new developers or helping people learn the language for the first time, I don't know how often you're going to use top level statements. But top level statements is a way for us to get away from our good friend public static void main. Since time immemorial, we have had to say that there must be a class, and the class must be named something, usually program, because that's how Visual Studio templates it, and that class inside of it is going to have a static method that might return void, might return task, but either way is going to take a string array of arguments as an input, and that is the starting point of your application, right? Well, in C#9, they said, we want to make it easier for people to just get in and start writing code. And so they said, if we see a class file, like this program CS file that I'm within right now up here in Visual Studio, if I see this, it doesn't matter what the file name is, it could be named, foobar.cs, but if I see one of these files and it has no class, I will assume that is your entry point. And so at that point, we can have a using statement and get straight to writing code. And so here at the very outset, you can see that we have now a ability to go, give me a console write line, say hello world, which is of course where every good language talk has to start, because if you don't start with hello world, they send the ninjas after you to take you out, and they never let you teach languages ever again. So we're going to just run this, and sure enough, as you can see, we get a successful execution of hello world, even though we had not yet done anything. Now, you can even inside of this come in and go, hey, I'd like to declare a class. New class. And then I could come in here and say that I would like to do a console write line. of the type of foo, and I want to get its full name. And if I do that and run this, you will see that I indeed get that is a class and its full name is foo. Please note, its full name is not, my project name is C#9 features. It is not C#9 features.foo, even though full name should include the assembly, or pardon me, the namespace, because there is no namespace for this class that you are in at the current time. Okay, the compiler is generating a type for you, right? To come in and work with, but what that type is, you don't have to worry about. All right, so we're going to stay in top level statements just to keep the distractions to a minimum as we go through the talk today, but that is top level statements at a high level, and I want to just start off with that. Now, next up is my favorite feature that changes how I write code and, in C#9, and it is the concept of init-only setters. So here is our situation. Imagine, if you will, I had a class and we're going to make a class named person, okay? And inside of this class named person, I want to be able to have a first name and a last name. Easy enough. Now, previously, if I wanted to create something, and this is going to be a theme for us today of creating a class where I wanted to limit when things could be modified, right? Well, if I wanted to do that and make it so that, let's see, I have a string. We'll do, well, here we'll do the auto-generated properties version of this first. So if I had a string and string property name first name, I could previously do this. Some of you may not even know that this is a possibility, to say that I want a public getter, but I want a private setter, right, to be able to do things. And so if I did that, and then I came in and said, yes, I want this exact same thing again, except for the fact that I want it to be last name, right? Then I could come in here and create a constructor that said, I want to construct this class giving a first name and a last name. And this was how we did essentially read-only automatic properties previously. The problem is that these are not truly read-only in this aspect of a read-only field. If we had a private field over here that was a private read-only string that was named first name, right? And we did this read-only can be assigned perfectly well in the constructor. That's perfectly valid to do. Okay, we'll help it with the clarification there that I'm talking about that property. So we can do that here, but the problem is if I add a method down here, method void do some work, okay? And inside of here, I were to go and say, I want to assign this dot first name with a little f, so I'm getting the field, and attempt to make that the word Tim, I'm going to get an error telling me that that's read-only and can only be assigned in the constructor. But if I try to assign the property first name, I can do that because this private setter is private. It can be used anywhere in this class. And so some people were not being able to use automatic properties for their purposes because they wanted assign once properties, properties that were assigned only in constructors, not anywhere else. They wanted a behavior like read-only, like a read-only field, without having to manually create a backing store. To that end, Microsoft listened, and in C#9, they've shipped a new shortcut for our automatic properties called Init. What Init does is say you can only assign this inside of a constructor. If you're inside a method, you can now see that you're going to get an error indicating that it can only be assigned in an object initializer or a constructor. So this is an excellent way to take control of things. Now, because of this, doing this on data types, on something like this that is a DTO, that's all well and good, right? But what if this weren't a person class per se? Let's say that in my system, I had an interface that was named, I don't know, iRepository. It doesn't really matter what that does. I just want to be able to reference that type, okay? And let's say this wasn't person, but this was a person controller, right? Well, for most folks who do dependency injection today, right, they would come in and probably write a private read-only iRepository, okay, here, and then they, an iRepository named repo here, and then they'd go ahead and add a constructor, and they would have this take an iRepository named repo, and inside of this go this.repo equals repo. So, and this works perfectly well. If I use the word public, I have to use it everywhere. Okay, so now we have a perfectly happy piece of code that is like, yep, we can do this. Now, I would like to show you something that is true and that I have found very, very useful, which is that that is very nearly the same number of characters, and as a matter of fact, is even being overly verbose because that's going to default to private anyway, so that you can really terse this up and go, hey, let's use these init only properties to even allow us to create private properties that we can dependency inject into. So I use init only properties in this fashion all the time in my classes now, just to go, I expect to do this. I'm going to have access to this this repo anywhere I want to inside of the class. And I know that anywhere else I can only get it, but it can be initialized only in my constructor, which is perfectly good for dependency injection. So I use this all sorts of places now to be able to keep things terse and to make sure that I know when things are going to be allowed to change. Now, with that said, that's an interesting thing. Will, do we have any questions over those first couple of items?
No, at this time, there are no questions.
Awesome. Okay. Just as a reminder, if you have questions, feel free to put them in the Q&A. I'll ask roughly after each of these sections as we go through. But yeah, just wanted to make sure that I pause before we get too far away from the context, and most importantly, before I go deleting a bunch of code. All right, so we have now shown off our init only setters. The next piece we're going to talk about is records. And records really are the thing that if anything is going to change your world inside of C#9, it is going to be records. Records can radically change what you're doing. A record is a new type, sort of. It is a type that is a class. It is a structure that behaves like a class from all perspectives as a language structure, but it has a lot of things built into it that classes do not. And it is meant to represent read-only data. This is the important thing. We're trying to create a structure that says this data is fixed, and we are never going to mutate the original class. We are going to simply act on that class as a set of data. We are never going to allow modification of that. So I started with init-only setters because records use init-only setters by default. So we're going to start and create a new record. And as I mentioned, it looks like a class. So instead of the class keyword, we use the record keyword. And now we can even go so far as inside of this to say I want a public string. That's our first name, right? And we can do init-only values here. We can do it again and do a get init. And so now I have a first name and a last name. And with that, I can now write a constructor that allows me to say, take the first name and take the last name, and we will assign those to first name equals first name, last name equals last name, like so. With this construct, let's go look at what we can do with it, shall we? We've declared one. This is a simple record. Now let's go ahead and use this. So I can create a variable that is named Tim, and I can create a new person, and I can provide Tim and Rayburn here as the values. And when I do, now we can start, now that I have an instance of this, I can really start showing you some of the amazing things that come with records that you don't get by default in other pieces. The first of those that is going to require me to have a second. So I'm going to create my brother Mark as a class, or as an instance of the person as well. And we're going to do a console write line here that says that I want to know if a Tim is equal to a Mark. Okay. Now, these this equality that we're about to do, if I run this, we actually get a false here. Now, we'd get that false if these were just different objects as well. But in actuality, what we have here is that when we're dealing with a record, the compiler is now automatically generating an equals method that is based on the values of the properties on the record. So we get a value comparison being done for us in equals, not the default object implementation, which is a pointer comparison of the two. So furthermore, besides for just equality that way, we also get an implementation of get hash code. So I have a get hash code for Tim, and let's go ahead and get a hash code for Mark as well. And these are also based on value. So I get one hash code here and another hash code here. Now, how do I prove that to you? How do I prove that that what I just said is true? Well, how about this? What if I were to create a variable named Tim2, okay, but assign it the same values? At this point, if I compare Tim2 to Tim, I should get true, because if these have the same values, they're not the same object. We're newing them two different times. But they do have the same values assigned to their properties. And what you're about to see is that we will actually get a true back from this this equals call, and we'll get the same hash code for both Tim and Tim2, but Mark, who has a different property for first name, property value for first name, will get a completely different hash code. So let's see that. And there we are. We get true for the comparison of Tim to Tim2, because those are actually equal objects. If this was simply a class, that would absolutely be false at the current time, because they'd be different instances, but it doesn't matter. We're actually comparing values. And then, as we can see, the hash code I get for Tim and the hash code I get for Tim2 are identical, but the hash code I get for Mark is different. Now, if you're most devs that I've run into working in the field, you're probably like, but Tim, I literally never use hash code. And I'm going to tell you that is almost true, which is there is a construct that cares very much about hash code that you use on a very regular basis, I'm sure, but you just don't think about the fact that it uses hash code. Okay? And that is a dictionary. And so if I create a dictionary of person and integer, okay, here, I can then go in and assign, I have to add the using statement, because dictionary is not in system. That is in system collections generic. Now that I've done that, I'll be able to see my add method here. Okay, and it'll say, give me a person. There you go. We'll do that. We'll give it a value, and we'll say 100. Let's also add Mark into this and give him the value of 200. And then finally, let's go ahead and add the value of Tim2 and attempt to give it the value of 300. So, and when I'm done with all of that, let's just go ahead and just to prove that we reach a point, let's go ahead and console write line dictionary and ask it for a count of what it has going on in there. Okay, so just give me the count of how many entries are in that dictionary. Let's go ahead and run that. And this will be the debugger stopping me and going, Tim, got some bad news for you. I already have an entry with the same key in this dictionary. And you'll be like, no, you don't. That's Tim and Tim2, those are different keys. They're not, because of the fact that what dictionary uses under the covers to know what that key actually is this hash code. That's how it's actually keeping track of this. And so that since the object hash code for Tim2, as we discussed, is the same as Tim1, I cannot have them both in the same dictionary and working beside one another. But that is sort of its own blessing as well, because if I were to turn these statements just minorly around and say, hey, instead of doing an add here, if I were later on in the process and I simply wanted to index or access using Tim2, I want to come in and assign the value of that to the value of 300. This is perfectly valid. And in fact, if I then use Tim to access that value, we will get 300, not 100 out of this. And in point of fact, we did. There's our 300. So our records automatically have equality. They automatically have hash code. That's awesome to begin with. They do even more for us than that, though. Let's go ahead and shut this down here. Let's cut back our code a little bit. Let's now instead talk about what we get. ToString. So if you call and a console write line on an object, and record is still an object. It does still inherit from object. Hence, we have equals, we have hash code, etc. If I do a console write line on this, normally I would just get the type. I just get that's a person. You wouldn't know anything else other than that's a person. Well, if it's a record, we also get a better implementation of toString, which is what gets invoked here, for us automatically. So now the toString of that record indicates not only the type, but all of the values that have been assigned to it. So we get a value-based, member-based toString created for us automatically. Now, the final thing is, it's all well and good. We have a read-only thing. I cannot come in here and reassign the first name of Tim to Mark. This isn't valid code because of the fact that that is a init-only property that's been created, as we know right here. But sometimes I need to be able to work with a value of a record with a modified value. So I want everything about Tim, except I want the last name. We'll change the last name to Johnson this time. Okay. So I'm going to go ahead and assign Tim2 here to be equal to Tim. And then there is a wonderful new keyword called with. And with allows us to say, I want everything about Tim except what I express in this initializer block right here. And so then I can come in here and say, I want Tim with a last name of Johnson. And at that point, I can console write line that Tim2 now and run this. And I get Tim Johnson instead of Tim Rayburn. Easily done. So this with construct allows us to say, when we need to modify values, we do this. But what is actually happening here is that we have cloned Tim and then modified one of the values as we are cloning it. The original Tim is unmodified. If I move this console write line underneath here, we are not changing Tim. We are creating a wholly new instance in Tim2 that gets this. So let's go ahead and show that. So these two things, the Tim is still Tim Rayburn, and the Tim2 is Tim Johnson. And if I were to come in and take, let's see, console write line, if I were to come in here and say I want to cast as object the variable Tim, and then I want to call. I don't even know that this trick will work. I'm off script, but I'm curious to see if this works now. If I were to do this for these handful of classes and say Tim and Tim2 get the hash codes here, and then let's run this down here and get Tim2 again. I don't know if I can get to objects implementation of the hash code this way, but we'll try it. Nope. Those even still, I'm getting the record implementation of hash code. So I was trying to see if I could run to objects implementation of the hash code to show you that these that new pointers were being created. But the point is at the end that this is what comes out of this is a clone of Tim with a modification. It is at that point not Tim2. The pointer that Tim2 was pointing at has been modified to a whole new instance. This previous instance of the Tim class that was equivalent or was equal to Tim, but without things, gets just sent away, okay, into garbage collection. So that is a good run through of some of the basic how to operations of record, but there's a lot more still to come with record. So I want to pause here and say, do we have any questions so far about the record pieces or anything else that I've gone over previously?
Yes, we have one question so far. Do you have any tips on maintaining the advantages of records when one of its properties is enumerable or any other reference type?
So certainly, the first is to, yes. So it is worthy of note. If you put a reference type here, right, then you do get into the situation of course that you can modify the structure or the length of an array or the length of an enumerable, etc. Or pardon me, you can modify the length of an enumerable. That's the important part that I'm about to get to here. So my answer is, if you're trying to use records, eschew enumerable in favor of arrays, okay? Because while it is true that if I were to add in public, IEnumerable of string here, that is the aliases that this human being is known by, right? And I set this up as get init, and then I say, all right, I likewise will take an IEnumerable here and do this and call this aliases. Let's go ahead and add that in here. So now aliases equals aliases. All right, so I now have modified our structure to include a enumerable. And I'm going to go ahead and do, oops, that is not what I wanted to do. Do Tim's aliases here, and I'm going to make a new list, right, of string, and then we're going to come in here and say that Tim is also known as Timothy, okay, and Tim is also known as that bum, okay, and so those are my aliases. We initialize this class passing my aliases, okay? So the at the heart of the question is now a couple of things. So if I do a console write line here, right, and I do Tim, and I'm going to also write out the hash code because this is about to be relevant, okay, and get hash code. Here we go. All right, so if I do this, this works perfectly well-ish. If I write this, I see that I have a value that is this, this, and this, and I get this generic list being used. And I have a hash code that is output right here for me. Well, the problem, as was hinted at, is I've just introduced a reference type into the midst of this. So that reference type gets me into the conundrum of, if I come in and say, hey, let's do one more write line here on this. Let's do Tim dot aliases, and I want to go and do, I'm simply going to, how do I want to do this? Probably do string dot join on using a comma to separate them, and here's an IEnumerable string. That'll work. Okay, so if I dump out the aliases as well, and then I'm going to come in here and just go Tim's aliases, and I'm going to add a new member to that Tim's aliases. That is going to be Superman. Never be Superman, by the way, but that's besides the point. I'm going to grab that, and then we're going to dump this same list of things out. So I've modified the list. I've modified this IEnumerable. And the first problem that should be an indicator is that this even is valid code, right? Because we wanted a read-only type, and I'm modifying something that is used on Tim. And if I run this, you will see, in point of fact, several concerning things. I get a person, the first time I dump it, I get a person and it notes that the alias is this list of string. And inside here, I get a hash code that ends in 863. And the aliases are Timothy and that bum. I then go and do the modification. I get the same toString out here. I get the same 863 hash code, but I've added and modified Superman onto that list. That is not aligning with our goal of trying to stay read-only. As such, we're going to need to make a change. We want to model a multi-entry thing, but we chose the wrong structure to do it with. What we need to do is, instead of making this an enumerable, we need to make this a string array. And if we use the string array and likewise change the declaration here to be a string array, then at the point at which we do that, we can come in here and just do, oh yeah, by the way, I'd like a 2 array off of that guy just to make life easier. I can do something that makes that valid. So I'm now creating an array. I could also have just done it by doing new string array here, right? And get rid of this. Okay, so I created it as an array instead. And now I get this. I get an error at the add, because of the fact that arrays do not let you add to their pieces. Now, so with that, I can't add. That was one of my potential problems. The next potential problem is, what if I come in here and simply say, at the 0th member of the array, actually, let's make it the 1. Let's stop being a bum and start being Superman. What if I come in now and say, I want the first member of the array, which is that bum, to be Superman. If I run this, you will say, see, I still have the same problem. So you can stop adding people from adding entries in, but the structure does not easily align currently, because array does not have a concept of it being value-based by default. Now you might look at this and go, well, that's terribly unfortunate. The answer is yes, but it also lets me talk about what Microsoft is talking about for C#9. Microsoft would tell you that almost all of the differences, all of the things they're doing today inside of record classes, they want to be able to do in other classes as well. So over time, we're going to see them introduce a structure where classes are value-based in their hash codes, so that we get these changes out, okay, and actually can have these sorts of things do. If you're trying to avoid add, using array is a good start. But if you are in a situation where somebody is going to be able to explicitly access values, then at that point, the only thing you can do is hide access to this altogether, aliases from them altogether, and simply give them method level access to the data, so that they don't get the ability to modify the reference type for you. You have to hide the reference type from them. It is not the easiest thing, but it can get the job done if you need to. All right. With that, let's talk about the next portion of it. This was our talk about records. Now we're going to talk about simpler records. So as it winds up, I have more or less been lying to you guys this entire time, which is what I have here for a record is the most large, the most complicated form of a record that you can write. If you think about it, and start thinking about, what do I actually need to know about a record, right? I need to know a list of properties that need to be on that record. there is a coupling between those properties and the fact that since they're init only, I need them to be on the constructor as well. So why do I have to say string first name here as well as string first name here? That seems like I'm repeating myself, and I'm a developer. I'm lazy and I don't like repeating myself. Likewise for last name. And then once you've done that, you've said, okay, well, maybe actually I don't need any of this. If it's a thing I'm going to do in a record and I know I'm in a record, then I don't actually need to specify, because I should know that if I'm taking it on the constructor, there has to be a property to go with it. And as a matter of fact, I kind of know I just need a constructor, right? So why do I even need any of this at all? Why can't I just terse this all up to look this? As it happens, once you remove aliases up here as well as no longer being part of this demo, this is a perfectly valid record declaration for person that says, I would like to just tell you what the parameters of the constructor are. And so I've done that. And in point of fact, you will see that if I open up the IntelliSense here, that first name and the last name are immediately available to me. And if I come in here, I still have a property named first name and a property named last name. I still also have hash code and all these other wonderful things. But one thing has appeared that wasn't there previously, which is this method called deconstruct. So if I declare a record in this terser form, Microsoft creates a way for with the compiler for us to be able to to piece apart this class into the other pieces, into the pieces I need. So I could now come in here and say, I would like to get a create a variable named fname, and I would like to create a variable named lname. And I simply want to have those assigned from the value Tim. And as soon as I do that, you will see the compiler is happy with that line. And if you're a C# dev, you're like, how can the compiler possibly be happy with that line? And the answer is because C# knows that this record can be taken apart into a first name and a last name, and ordinarily it will come apart first the first name, then the last name. And as such, it will make this a string and this a string for us. And we can prove that by coming in here and doing console write line, right? And let's go ahead and print out fname, and then we'll do it again and print out learning to type, print out last name. And as soon as I do that, I can go ahead and run this code. And you will see that, in fact, I got Tim and Rayburn separated into two different variables there. Moreover, it gets even better. What if I were to come in here and say, hey, I also want to track an age? And disappointing you all to let you know that I'm actually 48. I can do that. As soon as I do that, this line is no longer happy. Our line 5 is unhappy with me. And if I float over for Y, it will tell you that deconstruct requires returns three things: a string, an outstring, outstring, outint. And I have only taken 2 of those things, so I don't know how to turn it into 2 values. But all that requires me to do is to come in here, specify age, and then if I do that, I can now have age captured here as well. And as you can see, when I run that, I've now got 48 down here. I also want to call out one other thing, and this one really blew my mind when I first did this. The type of the age variable is actually an int32. And so what that means is that this singular var specified here, where we're saying, I don't want to tell you the type because you know it, compiler, that one var does not have one meaning. For fname, it's a string. For lname, it's a string. For age, it's an int. And that the compiler just handles that for you. Now, one last thing about the terser form of records and how you can use them. It is important to note there's still a set of curly braces down here. Records can have methods on them. Those methods can do calculations and things like that, but they can't actually modify the structure because they're a read-only structure. The other thing that I want to show you very quickly here is that there is a new syntax. This is not technically a record thing, just for the record, but this is a fit and polish item inside of C#9, which is that this is a perfectly valid object declaration. So we have had var for some time now, and var could infer what you were trying to do by the fact that the right-hand side of the assignment for a var, and you had to be assigning it, would know the type, and so var would become the type. In C#9, they've essentially allowed us to flip that contextually, which is to say, if you have declared a type, and then you just do a new, as soon as you do a set of parentheses after a new, they're like, oh, well, you must be trying to construct person because you've told us this is a person. So I don't even have to tell the language which type anymore because the variable has told it the type. And when I do that, I'm off and running at the races and I get full IntelliSense. It knows I'm building a person, etc. Now, where this differs from var, importantly, is that split is valid, which is on a completely separate line. Later on, I can simply come in and go, I want to create a new Tim. Tim is defined as a person, and so I can now use this new initializer syntax here, constructor syntax, pardon me, to come in and do this, and that is perfectly valid, and that is still newing a person. That is importantly different, of course, because of the fact that you cannot do the same split with var. var with simply Tim2 says, sorry, you need to tell me the type. You can't have a naked var, if you will. But you can use the object initializer new here, even with for calling the constructor, even if you're on a separate line later on, because, and this is the reason why, line 4 in this situation is enough for .NET to know allocate memory in this way and shape because I'm talking about a very specific type. There's no ambiguity as to what Tim is because I've given it the type. And at the end of the day, it is worthy of note that this, if you're a keystrokes counting person, the fact that line 5 is shorter than line 4 actually means that if you went to var because you were typing less, because you didn't have to type the previous version of it, which was this, person Tim equals new person, right? If you went to var because that made things shorter, then this structure where you go away from using var and instead use the type declaration properly to begin with, and then just use new and open paren is actually going to be cheaper. It is fewer characters, and very specifically fewer characters by 3 characters, which are V, A, R, and space, because you're losing those 4 characters that are the difference between the characters on line 4 and line 5. So if you care about keystrokes, this is a one to get past. All right. So this is records and simpler records now. Last thing we're going to do here is we're going to talk about pattern matching. So we'll stick with this version of Tim here, and we have come in and we're working with Tim. We perhaps have decomposed or deconstructed Tim into all of these variables. Let's say I wanted to write a extension method that checked age to make sure, because there are lots of values that are valid for an integer, like negative 2.1 billion and positive 2.1 billion are both valid values for an integer, but they don't exactly make sense for an age. Okay, so we're going to come in and write an extension method, public static class of extensions here, just place to stick my extension methods. And then we're going to come in here and do public static bool, and we're going to create an extension method that says this is a valid age. And we could write this against any of these pieces. Let's start by writing this simply against integer here. That is going to be our age. Now, if I were writing this and I wanted to be able to do this, I could write this as a return here where I said that age has to be greater than or equal to 0. You could be a newborn, sure, okay, and age needs to be less than or equal to 150 years old. For the record, like 122 and a bunch of days is the oldest human that we have a record of at the current time. So I can write this, and this is a perfectly valid way to write this. But this is also the big, long, expensive way of writing this again. So little hint at a wonderful C#8 feature here is expression bodied methods. And so now this is the same piece of code, but instead of having curly braces and a return statement, I can simply lose the curly braces. This is perfectly valid code that does what I need it to and is off and running at the races. But this is still not pattern matching. What if I wanted to express this same thing, but I wanted to express it like this? I wanted to say that age is, and this is moves us into a pattern match scenario. And then I could say that age is greater than or equal to 0, and it is less than or equal to 150. This is a pattern, and it is also perfectly valid C#, causing several of my friends. I'm a former VB developer, for the record. I know for a fact developers I have spoken to over the years who would be stomping their feet on the ground and saying the letters A and D will never be a keyword in C#. You're wrong. There it is. It is now a keyword in C#. And but this pattern will get evaluated and is exactly what you would expect, which is by a console write line. And I come in here and say age is valid age and call that extension method. And then we go run this. That works perfectly well. And we get a true back from that. So that is one example of using pattern matching. to be able to do things. Now, I've gone a little while since I asked about questions. So, Will, are there any questions?
There's kind of a clarification question about records
Yep.
and using enumerables again.
Yep.
And couldn't you, so for reference types, couldn't you make sure, if you're trying to have a best practice to keep it immutable, couldn't you only enforce as a code practice that you want to only use other records when you can, and then for enumerables, make use of the either immutable lists that are in C# or the read-only collections? Could something like that work for you?
So yes, generally speaking, you want to avoid using anything other than other records. I agree with that statement. To my knowledge, the immutable lists, and I would have to go and look this up, but I don't believe that the immutable lists that exist actually change their hash codes and their equality based on their members. And if your type isn't doing that, if its hash code doesn't change when you add a new member, then the records hash code would not change should it have a different structure, and that would in turn be the end of the problem. But I'd have to look that up. And to be honest, most of the places I've been doing this, I've been using them as flat structures, so I don't entirely know is the actual answer to that. So maybe. All right. And that was the only question we had, or the clarification we had there?
That was the only question, and just a reminder, we have just a couple of minutes.
Yep, I am aware. So the one thing I was going to pick off the top of our bonus list here, just to get to that, I wanted to show everyone, because it is one of the things that I truly do believe is overlooked in the awesomeness of C# 8. Okay, is if I had a method here that was do something, okay, and inside of this do something, I wanted to create a file stream. Okay, get a new file. So let's go ahead and do system.io.file.create, and create is going to return me a file stream here. And so let's just say, C foo.text. Okay, so file streams are disposable things, right? So I come in here and I have a stream, but the stream is disposable and I'm not handling that here. Okay, so traditionally speaking, if I wanted to use this, I would come in and do this and create a using block. Pardon me, using block that would allow me to do work with here with the stream. And this is all well and good until you wind up with this structure nested 3 or 4 times, okay? Because it very quickly becomes all right, well, how many levels of indentation do I actually need if I'm working with 3 streams here? This sort of gets absurd at this point. Let's assume that we're not actually modifying the same file multiple times. Okay, this gets absurd. And so there is a wonderful new feature in C# 8 that says, you want to know something? If you lose the parentheses around the using statement, like so, then you can do this. Semicolons at the ends of each of these lines. And down here, stream is absolutely still in scope. And so these variables will all be disposed at the close of this method. So that's my one little bonus throw in. It's a using declaration. And with that, Will, I'll turn it back over to you.
Great, thanks, Tim. That was really insightful. I would like to thank you all for attending Improving's virtual Lunch and Learn. The recording of this session will be available in a few days from our virtual events page at improving.com. We hope you enjoy the rest of your afternoon.